everyone, welcome to Physics by Aaryan. I'm very happy to welcome you all. In the last lecture, we discussed spherical polar coordinate system. In this system, we will be discussing cylindrical polar coordinate system. Many times in physics, we have a cylindrical symmetry. For example, let's say you're finding the magnetic field due to long wire. So now the wire is like an axis of a cylinder. So your symmetry is cylindrical symmetry. In that case, it is best that you use the cylindrical symmetry, cylindrical polar coordinate system. In the last class, we learned that for spherical polar coordinate system, you basically need three things. One is r, theta, and phi. Similarly, in cylindrical coordinate system, you will be needing three things: rho, phi, and z. So what is rho? Number 1 point. So let's say you have any point P. The point P can be anywhere in the space. So you have some point P. The distance of this point P from the axis is known as rho. So you can clearly see this point P is at a distance rho from the axis. Now what is phi? So let's say you take another point. For example, let's take Q point. So now you connect this Q with the axis. So you have connected this Q with the axis. The angle which this vector is making with the x-axis is known as phi. So you connect a vector from axis to the point, your point of interest, and the angle which that vector Q or that vector rho is making with the x-axis is known as phi. It is the same thing which we studied in last time. In spherical polar coordinate system also, we studied phi. So the phi there and phi here is exactly same. There is no difference at all. And what is z? Z is a z distance. You know, z is a distance in the z axis. So let's say this point P, then the distance in z axis is given by z. So these are the three things that you need in order to define your cylindrical polar coordinate system. What was the next thing that we did? We did the relation between x, y, and z and r, theta, and phi. Similarly, we will find the relation of x, y, z and rho, phi, and z in this situation. So in the last class, I already told you if this is x vector and this is rho and the angle between them is phi, then what will be x? X will be rho cos phi. If this is y and the angle between phi and y is 90 minus phi. So this is your rho, this is your y, and angle between y and rho is 90 minus phi. So what will be y? Y will be rho cos, or let me write here, what will be y? Rho cos 90 minus phi. Or simply I can write rho y equals to rho sine phi. So this is what I have written, y equals to rho sine phi. So always remember this rule. If there is one vector, other vector, angle between them is phi, then A is equals to B cos phi. As simple as that. And what is Z? Z is Z. We don't have to make any particular relation for this. Then what else we need? We found x, y, z. Now let's find the inverse relations. Let's find rho, phi, and z. So if you square and add first two relations, so square x, square y, and add them. So you will get rho equals to under root x square plus y square. If you divide 1 and 2, you will get phi equals to tan inverse y by x, and z is obviously z equals to z. So very simple rules. If someone gives you rho, phi, and z and asks you to find x, y, z, you can use these relations. And if someone gives you x, y, and z and asks you to find rho, phi, and z, you can use these relations. Then what was the next thing which we covered? We covered scale factors. Scale factors. Now, scale factors or H factors, we can call them anything. So there are three components. So there will be three scale factors. One will be for rho, one will be for phi, and one will be for z. So the scale factor for rho is 1. Scale factor for phi is rho, and scale factor for z is also 1. So remember this, very important for rules. Then we come to line elements. What are line elements in the last class? Small lengths. So we covered already what are line elements? Small lengths. So what will be the small length along row? What will be the small length along row? It will be h row into d row. What is h row? H row is 1, so it will simply be d row. What will be the small length along phi? It will be h phi into d phi. H phi we covered is row, so it will be row d phi. What will be the small length along z? It will be hz dz. Hz is 1, so it will simply be dz. So this will be your small length along phi, rho, phi, and z. Okay, if it is clear, let's move to area elements. What are area elements? Small area elements. Small areas. So small areas are known as area elements. So number one area element is when rho is fixed. So when rho is fixed, the direction of area element will be rho cap. And what you will multiply? I already told you last class, other two, dl phi and dlz. So just put the value of dl phi and dlz, you will get rho d phi dz into rho cap. What will be the area element if phi is fixed? So if phi is fixed, the direction will be phi cap and you will multiply with dl rho dlz. So just put dl rho dlz value, you will get d rho dz phi cap. What if z is fixed? So if z is fixed, you will simply say dz is daz is dz. So daz is simply not dz. Daz will simply be, what will be the direction? Z cap, and what you will multiply here? D rho d phi. D rho into d phi. This will be your, and multiply by rho. So this will be your daz. How I got here? I got here by using, I will multiply by dl rho and dl phi, and my direction will be z cap, and I know dl rho is rho d. So dl rho is d rho and dl phi is d phi multiplied by rho. So I will get the same set. So you can derive any of these area elements. Now let's see what is volume element. So what is volume element? Volume element we already covered is a small volume, and it will be dl rho dl phi into dl z. If you put the values, you will get rho d phi d z. Okay, I hope it is clear till here. It is same as last lecture. Now, what are position vectors? Position vector is xi cap plus yj cap zk cap. X, y, and z value you have already found, so just put it, you will get your position vector. Unit vectors in the last class I discussed. If you want to find rho cap, so what you will do is you will derivate your position vector with rho, and you will divide it with the magnitude. Because in order to get unit vector, you have to divide with the magnitude. So if you do this, you will get this answer. Similarly for phi cap, if you want to find the phi cap, you will derivate your position vector with phi and divide it with the magnitude. So you will get minus sine phi plus cos j cap, and z cap will be z cap. Z cap is z cap. There is nothing more in that. So we can write z cap or k cap. Anything is fine. Okay, now let's come to gradient, divergence, and curve. What is gradient? I already told you, you can take a gradient of scalar quantities. How do you define it? Curly f by curly rho cap. And you divide it with the h factor of rho, which is 1. H factor of rho is 1, so you have to multiply it with 1. So then plus curly f by curly phi. So if you divide it with the h factor of phi, which is rho, you will get 1 by rho times curly f by curly phi. And in the last, you say curly f by curly z. And again, the h factor of z is 1. So here 1 is there. So you can ignore 1. So your final answer will be this. Curly f by curly rho cap plus 1 by rho curly f by curly phi cap plus curly f by curly z k cap. Now, next part, divergence. Same formula as before. So the same way in which I found in the spherical coordinates, now you just have to replace the h components. That's it. That's it. The formula is same. You only have to replace the h components. So you have to replace the h component of r with h component of rho, h component of theta with h component of phi, and h component of phi with h component of z. So simply what you are doing is you are converting r theta phi into rho phi z. So if you do this in the last analysis, this will be a good practice for you. If you do this, what you simply get is this relation. So this is very important relation. Initially, these looks like a very long algebraic formulas, no physics at all. And I truly believe that there is not much physics here. But these formulas are very important if you really want to solve the questions very fast, or you want to come to the conclusions very fast. So in electromagnetism, many times we will be using these formulas directly. So it is best that you practice these kind of questions and you solve a quiz after this assignment. And I will really recommend you, whatever formulas I have derived here, you should try to derive them by yourself. So you can actually very quickly derive this whenever you need this in your actual questions. Okay. Same thing with the curl. So again, replace the h factors in the curl of spherical polar coordinate system. You will get the exactly same answer. And you can actually see, if you do this, you will get this answer. So this can be your homework assignment, that you can actually replace the h factors. I have given the entire detailed derivation. If you do not understand how to do it, you can refer here. There is no problem at all. Okay, these notes are available in Telegram channel and also in the course page of website. Okay, so this is what I wanted to tell you, that gradient, curl, and divergence. Now let's solve some examples. Number one example which I want to cover is, if I give you xyz, which is again 1, 1, 1, and I ask you to find rho phi z, what will be that? So rho will be under root x square plus y square, which will be under root 2. Very nice. Phi will be tan inverse y by x, which is tan inverse 1, which is pi by 4. Very nice. And z is 1 given to you. So very simple question. Now, next example, let's find the curved surface area of cylinder. So we know the curved surface area of a cylinder is pi r square L, but let's derive this. Why are we deriving this? Because just to get a feeling. So what is the one thing that is constant? So if you see on this curved surface, wherever you go, the radius is fixed, r is fixed. So my r, or you can say rho, the distance from the axis is fixed. Anywhere you sit on a curved surface, you are at the same distance away from the axis, and that distance is equals to radius, and that is fixed. So if radius is fixed or rho is fixed, what is an area element that we will use? We will use dA rho, and dA rho is rho d phi dz, or I put the value of rho, which will be r d phi dz. So this is my small area. If I want to find the total area, I will do the integration. So my r is r. My integration of d phi will go from 0 to 2 pi, and my dz will go from 0 to L. So if you do this integration, you will get 2 pi r. Sorry, I mentioned pi r square. This is a volume. So the curved surface area is 2 pi rl. Okay. So 2 pi rl is a curved surface. So that is exactly what we got in our answer. Okay. Now again, I have given you 3 questions, in which one question I have asked you to find gradient. In other question, I have asked you to find divergence, and in the last question, I have asked you to find the curl. In the same way, the formulas already you know. You can see and refer the formula in the notes. So please try to do these examples by yourself. Just put the values into your formulas and try to come up with the answers which are written. Okay, so if you do not get answers by yourself, first try to do it by yourself. But if you are unable to get by yourself, you can look at the solutions which I have given. In case you find that any solution is wrong or I have made any mistake, please let me know in the comment section, because I can also make mistakes. That's not an issue. I will correct it and give you the correct solution. But to my knowledge, these solutions are right. So please practice this question so you can have a very good practice of cylindrical polar coordinate system. In the next class, we will move on to our next topic, which is Taylor series and Jacobian. Taylor series and Jacobian is also a very important tool in physics. So see you in the next class. Bye bye.